Number 9. Tungsten wire has a temperature coefficient of resistance of 0.0045 at 20 degrees Celsius. The hot resistance of a 100 watt 115 volt lamp is 132 ohms at its operating temperature. If 2580 degrees Celsius, determine its cold resistance at room temperature of 25 degrees Celsius. Okay, so let's understand the problem first. So, the temperature coefficient of a tungsten is given. We have 0.0045 at 20 degrees Celsius. So, therefore, our temperature coefficient at 20 degrees Celsius is 0.0045. Thing is, hot means final, cold means initial. Okay, so for a 100 watt 15 volt lamp is 132. So hot, so this would be 132 ohms would be our R2, and its operating temperature is, so this is our final temperature. How about your cold? This will fall our R1, and the resistance to the room temperature at 25 degrees Celsius. Okay, so let's recall first the formula. So we have our formula in solving the resistance with respect to the change of temperature is equal to R2 all over R1 is final resistance over initial resistance. This is hot resistance, this is cold resistance, is equal to 1 plus the temperature coefficient times the change of temperature. Okay, so let's evaluate the given. So do you have the value for temperature coefficient? Yes. You have a given for final temperature? Yes. Initial temperature we have at 20 degrees. Okay, here. Okay, that would be our T1. So we are asked to determine the cold resistance at room operating temperature. But before that, we need to determine our initial resistance or cold resistance before we can determine the cold resistance at a room temperature of 25. We need to solve first the initial condition. So solving that, for our R2, we have 132 ohms over our initial resistance, 1 plus the temperature coefficient. This is 0.0045 times our final temperature, 2580 minus our room temperature. I mean the temperature coefficient of our coefficient, that is 20. So solving for R1, your R1 is equal to 10.5431 3099 ohms. So this is our initial temperature. We are asked, we're going to save this to our alpha A. We're asked to determine its cold resistance at room temperature 25. So we're going to use our formula, but considering the temperature coefficient. Okay, so our formula, we're going to use the R2, our hot resistance, our cold resistance over the initial resistance, 1 plus the temperature coefficient at 20 degrees Celsius times your operating temperature. So doing so, our R1 is saved to alpha A. So this is our unknown, the cold resistance, and over the alpha A is equal to 1 plus the temperature coefficient at 20 degrees Celsius, that is 0.0045 times our operating temperature, which is 25 degrees Celsius. So solving for R2, which is now our cold resistance at operating temperature 25, R2 is equal to, that is 11.72923323 ohms. So this is our cold resistance at room temperature 25 degrees Celsius.